Welcome. This lesson is going to be on double angle identities, and we're going to first talk about where our double angle identities come from. So we've already learned about the sum and difference identities, and the double angle identities are a special case where the two angles, alpha and beta, are the same angle. So here we're looking at deriving the double angle identity for sine. So this is our sine of a sum that we've learned about. If we let beta be alpha, the same as the first angle, then what we get is the sine of alpha plus alpha. And applying that to the identity, it becomes this, and simplifying this, we end up with two like terms, both sine alpha, cosine alpha terms, which tells us then that the sine of 2 alpha, which is alpha plus alpha, equals 2 sine of alpha cosine of alpha. So that's one of our double angle identities. For cosine, so looking at cosine of a sum, if alpha and beta are the same angle, then we get cosine of alpha plus alpha. Applying it, we get this expression. And simplifying that becomes cosine of 2 alpha equals cosine squared alpha minus sine squared alpha. We can also get alternate forms of this one using our Pythagorean identity. Sine squared plus cosine squared equals 1. So replacing cosine squared with 1 minus sine squared alpha, and then simplifying, we get cosine 2 alpha is also equal to 1 minus 2 sine squared alpha. Replacing sine squared alpha with 1 minus cosine squared alpha here, then simplifying, we get cosine of 2 alpha is also equal to 2 times cosine squared alpha minus 1. We can also find a double angle identity for tangent using both the sum and difference identity, or the sum identities for sine and cosine, and the quotient identity that tangent is sine over cosine. So here we see that expression here. Sine of alpha plus beta over cosine of alpha plus beta would be tangent of alpha plus beta. If again we let beta be another alpha angle, then we get this, and simplifying this gives us 2 sine alpha cosine alpha over cosine squared minus sine squared. Dividing the numerator and denominator by cosine squared alpha gives us this expression, which simplifies to what we call the double angle identity for tangent, which is all you'll notice in terms of tangent, no more sines and cosines. So tangent of 2 alpha equals 2 times the tangent of angle alpha divided by 1 minus tangent squared alpha. So that's where they come from. Here is a summary of our double angle identities. So we have 1 for sine of 2 alpha. We have 1 identity for tangent of 2 alpha. And then we have 3 forms for our cosine of 2 alpha because of our ability to do those substitutions with our Pythagorean identity. All right. Here we're going to look at using those identities. We are given that sine of theta is equal to 2/3. We are also told here that theta is in this quadrant. So we have to interpret this using our understanding of radian angle measures. So this is our pi halves radians to pi, so this would be our quadrant 2. We're supposed to find exact values, and they should be in their simplest form. And we're going to start with sine of 2 alpha. So what we would do is figure out, using we have to do a couple of things actually. And probably the best thing to do first is to treat this as a triangle, right triangle, in the second quadrant, and find the third side that we don't know right now. Sine, remember, is by definition the side opposite the angle over the hypotenuse of the right triangle. And it's best if we draw that in the second quadrant where the angle exists. So we would draw a triangle like this. There's our right angle. This would be where our reference angle is, theta prime. Theta is actually over here, and theta prime is there, but it works the same for theta prime as for theta. And so we know that sine is 2/3. So that means the side opposite would be 2. The hypotenuse would be 3. Using our Pythagorean theorem, we can determine that this side would be the square root of 5. The problem is, though, because we're in the second quadrant, and we're looking at this as an x-axis, y-axis, as we do the unit circle, we have to realize that in the second quadrant, the x-coordinate here of this positioning would be negative. So this has to be a negative square root of 5. So now what we know, so we already knew the sine of theta is equal to 2/3. Now we can also determine that the cosine of theta, which is adjacent over hypotenuse, would be negative root 5 over 3, and that the tangent of theta, which is opposite over adjacent, would be 2 over negative root 5, which then we can simplify to negative 2 root 5 over 5, like so, which we may or may not want to do depending on what we're going to work with. We'll have to wait and see. All right. So going back to part A, sine of 2 alpha. Or 2 theta rather, sine of 2 theta. So we know that the sine of 2 theta, using a double angle identity, is equal to 2 times the sine of angle theta times the cosine of angle theta. And over here, we know sine of theta here is 2 over 3. So this becomes 2 times 2/3. And over here we determine the cosine of theta is negative root 5 over 3. And so simplifying this, this becomes negative 4 times the square root of 5 over 9. So there's our sine of 2 theta. For the second part here, we notice that we are dealing with finding cosine of 2 theta, but we're told to use this particular double angle identity. So here we have our cosine of 2 theta is 1 minus 2 times sine squared theta. So remember, sine squared theta means sine of theta, quantity squared. So that means that when we plug in the value for sine of theta, this becomes 1 minus 2, and our sine of theta is 2/3, so the 2/3 is what is being squared, the value of the sine of theta. Then simplifying order of operations, this would become 1 minus 2 times 4/9. And this would become 1 minus 8/9. And 1 is 9/9, so we have 9/9 minus 8/9, which gives us 1/9. So we can conclude then that our cosine of 2 theta is equal to 1/9. Tangent of 2 theta. So our tangent of 2 theta identity. This one, I'll be honest, when I use it for a while, it comes to my mind, but not always. So our tangent of 2 theta is 2 times tangent of theta divided by 1 minus tangent squared. So here we have 2 times tangent of angle theta divided by 1 minus tangent squared theta. Just want to double check, make sure. Yep. All right, got it right. So now what I'm looking at here is I know that my tangent, calculate my tangent over here. And you can use technically either form, whichever one you decided would be easiest to work with. It's really up to you. So this would become 2. I am going to use my simplified form here, negative 2 root 5 over 5, over, and then I have 1 minus, so again this tangent squared, remember, tangent squared theta means the tangent of theta is being squared. And so the tangent of theta is, I'm going to actually use this form here, moving my negative to the numerator, because I think that's easier to work with here. That is being squared. All right, so now what I'm looking at, simplifying this, the numerator here I get negative 4 times the square root of 5 over 5. In my denominator I get 1 minus, this quantity is going to become positive, negative 2 squared is 4, and the square root of 5 squared is 5. So I get 1 minus 4/5 in my denominator, and that's 5/5 minus 4/5, so that's going to be 1/5. So that's what I have right now. And then division of fractions, multiply by the reciprocal. So that is going to mean our negative 4 root 5 over 5 is times 5 over 1 and that gives us negative 4 times the square root of 5. So, conclusion is our tangent of 2 theta is equal to negative 4 times the square root of 5. All right. Looking at our second example. So for our second example, we are given that we know the tangent of angle theta is equal to negative 2, and we are told angle theta is between 3 pi halves and 2 pi, and that would be our quadrant 4. So again, what I would do first is draw myself basically a picture of where this triangle, related triangle to angle theta, would be located, which is in quadrant 4. So this is what my right triangle would look like. This is technically our theta. This is its reference angle, theta prime, which has the same sine, cosine, and tangent. Tangent is given as negative 2. So negative 2 has a denominator of 1. We know definition of tangent is opposite over adjacent. In this case, in the quadrant 4, this would be our y value, and y is negative. And this would be the opposite side, so this would be negative 2. And in quadrant 4, x is positive, so this would be our denominator, the adjacent side of positive 1. Using our Pythagorean theorem, we would get that the hypotenuse would be the square root of 5. The hypotenuse, which is equivalent to the radius of a circle, is always a positive quantity. X and or y can be negative. The hypotenuse of the related triangle, always positive. All right, so what this tells me, I have my tangent already. My sine of angle theta then is opposite over hypotenuse. So that would be negative 2 over the square root of 5, or rationalize negative 2 root 5 over 5. And my cosine of angle theta, which is adjacent over hypotenuse, would be 1 over the square root of 5, which rationalized is square root of 5 over 5. All right, so for sine of 2 theta, we know sine of 2 theta is equal to 2 times the sine of angle theta times the cosine of angle theta. So this is going to give us 2. Our sine is negative 2 times the square root of 5 over 5. And our cosine is square root of 5 over 5. So simplifying this, we would get 2 times negative 2 is negative 4. Square root of 5 times itself would be 5. So that gives us negative 4 times 5. 5 times 5 is 25. You could reduce the 5 and the 25 or multiply and then reduce. Either way, you're going to get negative 4/5. So our sine of 2 theta is equal to negative 4/5. For cosine of 2 theta, we are told to use this identity, cosine squared minus sine squared. So our cosine of 2 theta is equal to our square root of 5 over 5, quantity squared, minus our sine squared, which is negative 2 root 5 over 5. If you're using the rationalized form, you can use the non-rationalized as well. This becomes 5 over 25. Minus this becomes, so negative 2 squared is 4, square root of 5 squared is 5, 5 squared is 25, so we get 5/25 minus 20/25, that would be negative 15/25, which would be equal to negative 3/5. So our cosine of 2 theta is equal to negative 3/5. For our tangent of 2 theta, here's our identity. Remember, tangent of theta is negative 2. So this is 2 times negative 2 over 1 minus negative 2 squared. That would become negative 4 over 1 minus 4, which is negative 4 over negative 3, which would be positive 4/3. So our tangent of 2 theta equals 4/3. And that's the end of this example and the end of the lesson.